right, we're going to wrap up chapter 11 today. So the warm-up, a quick recap, is these linear equation solvings. So to isolate the x, we would first subtract 5 from both sides, giving us 3x equals 12. And then we would divide by 3, so our answer would be x equals 4. You could plug 4 in and check to make sure you did it right. That'd be a good idea. In number 2, we want to get all the x's on one side and all the numbers on the left. So if we move the 2x over, we would have 2x plus 1 equals negative 3. Bring the 1 over. 2x equals negative 4. Divide by 2. So x would equal negative 2. Next up, we have a divide by 7. To undo division, we're going to multiply. What you do to one side, you have to do to the other to keep the balance. So x equals 35. On this one, our 2 zeros are what makes each individual parentheses 0. So one of our solutions is negative 7, and the other solution is right here. When does x minus 4 equal 0? And that's when x equals 4. Anytime you have an x squared, you have 2 solutions. The next one, we're going to factor this. 2 numbers that multiply to give you 30. That add to give you 11 negative would be 2, well, let's think of the factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. If they multiply to give you a positive and add to give you a negative, it would have to be negative, negative. So negative 5 and negative 6 is our only one that will work. So x minus 5, x minus 6 equals 0. So our 2 solutions are 5 for this one and 6 for this one. You can always do that quadratic formula or completing the square also. And in the last little recap, we need to put everything on one side. I like my x squareds positive, so I'm going to bring everything to the left. And then are there 2 numbers that multiply to give negative 15 that add to give negative 2? So if you think of the factors of 15, you have 1 and 15. Since we're adding to get a negative, the bigger one's going to be negative. 3 times 5, and that's our answer. 3 and negative 5. Oh boy. Now it's working. So x plus 3, x minus 5. So our 2 solutions are negative 3 and positive 5. Applying that to square roots, radicals, to get rid of the square root, we need to square it. And what you do to one side, you have to do to the other. So if you look at something like this, we would just square both sides. So x would equal 36. Pretty smooth. You need to make sure that square root is isolated in our next problem. It is. So we would just square both sides. So we would have 81 equals 27x. And then if you divide both sides by 27, you would have 3 equals x, or x equals 3. All right, isolate the radical sign. It already is. Square it to get rid of it, because remember, the radical sign is the same exact thing as that. So if you square both sides, if you square this, x to the 1/2 times 2 is x to the 1. So that's why squaring it works. So 3x equals 1. Therefore, x would equal 1/3. This time, something needs to be done for the radical to be isolated. So our first step would be to add the 2. So the square root of x would equal 3. And then you square both sides. So x would equal 9. And you might want to just think about if that works. Square root of 9 is 3. 3 minus 1 is 2. Things are good. In this one, it already is isolated, so we're going to go ahead and square both sides. So x plus 7 is 25, and then you need to isolate your x to solve. So x equals 18. And the last one on this page, we would need to add the 1 first to isolate our radical sign. And then we would square both sides. And then we would solve this like a linear equation, which is why we did that review in the beginning. So subtract 7, and then divide by 3. So, same thing, but this time to undo a number next to a radical, we're going to divide both sides first to isolate our square root, our radical. And then when we square both sides, our square root is isolated. So x is 121. And I have that written twice, so let's not do that one. You know, I think what I was supposed to have is this. I think I typoed that. So in that one, you would square first and then divide by 22, but let's not do that. Okay. So letter A, we're going to multiply both sides by 4 as our first step. So the square root of x equals 8. And then square both sides. So x is 64. Why? I don't understand why I have these twice. Okay, maybe that wasn't a typo. Maybe it just copied. Moving on, let's go ahead and nix this one. So here we would multiply both sides by 5. So 2 square root of x is 20. And then divide by 2. So square root of x is 10. And then square both sides. Alright, now we have 2 square roots that are both isolated. So we could square both sides right away to get rid of both of the square roots. So we have 3x plus 2 equals x plus 6. And then we would just put all of the x's on one side, all of the numbers on the opposite side of the side that the x's took over, and then isolate the x. And then you could always check your work. Good idea. And it is actually a very good idea, because if you do get the square root of a negative, it won't work. In this one, you can't square this like that because of that. Because when you square something, you actually have to FOIL it out. And so we would just be making a bigger mess. But since it's equal to 0, you could just add the square root of x to both sides. So now we have a problem just like the one above, where each side has a separate radical that is isolated. So you can square both sides and then bring your numbers to one side and then divide by 2. Alright, this is explaining that if you get an x squared term, you're actually going to have 2 solutions. So you would put everything on one side. So this came from this by adding the x and subtracting the 6. And then you would factor and solve. So again, if you have an x squared, you very well may have 2 solutions, because x squared means there's most likely 2 x-intercepts. So if we do the first one here, we need to isolate the square root. And we have an issue because the square root's not going to equal a negative, so this is no solution right away. We are going to do a little bit with imaginary numbers, and the square root of -1 is I. There's a whole other set of numbers, imaginary numbers. So you can take the square root of negatives, not yet, next week. So it won't ever equal a negative though, ever. All right, let's go ahead and square both sides since our radical is isolated. So here we do have an x squared. Whenever you have an x squared, every single time, always, you bring everything to the one side so that you can factor. And I always like to bring it to the side where x squared is positive. You'll get the same answer either way. I just find it way easier to factor a positive x squared. So two numbers that multiply to give you 2, that add to give you 3, are 2 and 1. So our solutions are -2 and -1. And the last one, square both sides. So when you square something like this, remember we have to do that FOIL method, that double distribution. So this is really x squared minus 2x minus another 2x plus 4. So this side simplifies to x squared minus 4x plus 4. And we still have equals x. Whoa. So we're going to have to subtract that x to set it equal to 0. And then the two numbers that multiply to give you 4, that add to give you -5, are -4 and -1. It has to be two negatives because it multiplies to give you a positive and adds to give you a negative. So our two solutions are 4 and 1. And let's go back to both of these now. Remember how I said you really need to check your solutions? Well, let's check this one first. If I plug 4 into this, 4 minus 2 is 2, and the square root of 4 is 2. If I plug 1 into the problem, I would have 1 minus 2 equals the square root of 1. So I would have -1 equals the square root of 1. So 1 does not work. It's only 4 that works. So let's check and make sure these work. This one is a little tougher to plug in. So -2 equals the square root of, it doesn't even matter what it equals, because your square root can't equal a negative. So this one actually doesn't work. And x minus 1 would be the same exact thing. It's never going to equal a negative when you take that square root, because we're not going to be doing the negative part. And so that's an extraneous solution also. So this again would be no solutions, since we're doing the absolute value of the square root of x. All right. In the next and last section, the extension section, we're going to simplify these, thinking that x squared is the square root of x. You can actually have other roots of x. And if you have like a basic calculator or a graphing calculator for a couple later problems, this means the square root. There's also a button like that you would put the root number in first. So 4 cubed is 4 times 4 times 4. So 4 times 4 is 16, times 4 again is 64. -7 squared is -7 times -7. So that's 49. -2 to the 5th is -2 times -2, which is 4, times -2, which is -8, times -2, which is positive 16, times -2, which is -32. 5 to the -3. Remember, Negative exponents are actually improper to have. So if you think about this, I'm going to make a little table right here. 5 to the 0 would equal 1. Anything to the 0 power equals 1. In fact, we could actually put the answer to E right now as 1, because anything to the 0 power is 1. 5 to the 1 is 5. 5 to the 2 is 25. 5 to the 3 is 125. If you go backwards, 5 to the negative 1, see how we're multiplying by 5? This is an exponential equation. To go backwards, you would divide by 5. 5 to the negative 2 would be 1 over 5 squared, which is 1 over 25. Whoopsies. And 5 to the negative 3 would be 1 over 5 cubed, which is 1 over 125. So negative exponents are improper. We're moving them to the opposite side of the fraction, making them positive. In F, this means we have 12 359s on the top and 11 359s on the bottom. So that would mean we have 1 359 left. So like if you had 1, 2, let's say you had 359 to the third divided by 359 squared. Same thing, I just don't have to write out 12 of them. You see how this cancels and this cancels and you have 1 left? Whenever you're dividing, if you remember, you can subtract exponents. So this is like 359 to the 1. And then when you're multiplying, you add exponents. If you remember, like x squared times x cubed is x to the 5th. So 85 to the 6th and 85 to the 11th means we actually have 17 85s. We're adding the 6 plus the 11 to get 17. All right, so if we have 16 to the x times 16 to the x, that would be 16 to the 2x. Because x plus x is 2x. And over here, we just have 16 to the 1, because 16 is just alone, so it's 16 to the 1. So we have the same exact base. When we have the same base, we can set our exponents equal. So basically, my answer is 1/2. So this is explaining that 16 to the 1/2 times 16 to the 1/2 will equal 16. That makes a lot of sense, because the square root of 16 times the square root of 16 would equal 16. All right, so this time we have 5 to the 3x equaling 5 to the 1, because x plus x plus x is 3x, and we're adding our exponents. So our bases are the same, so we want to know when 3x will equal 1, and that's when x is a third. So this is telling me that 5 to the third times 5 to the third times 5 to the third will equal 5 to the 1. All right, this would simplify as 8 to the 3x, because x plus x plus x equaling 8 to the 2. Our 8s are the same, so basically I want to know when will the 3x exponent equal the 2x exponent, and that would be when x is 2/3. So that means 8 to the 2/3 times 8 to the 2/3 would equal 8 squared. And then 9 to the 2x equaling 9 cubed. So now I want to know when 2x will equal 3, and that's when x is 3/2, or 1/2. 3/2 might be a little better to keep it as, because the bottom number is what goes in the root sign, and the top number is what the base is powered to. So 9 to the 3/2 really means the square root of 9 cubed. 8 to the 2/3 really means the cube root of 8 squared. And if you have a cube root A cube root, if you multiply it by itself 3 times, it'll be gone. So that's why this equals 8 squared. Alright, so again, the square root of 36 is 6. The cube root of 27 is what number times itself again equals 27, and that'd be 3 times 3 times 3. So the cube root of 27 is 3. And the fourth root of 16 is what number times itself 4 times gives you 16. So that'd be 2 times 2 times 2 times 2. So 2 is your answer. You can also put that in your calculator if you're feeling a little overwhelmed. Those are the basic ones. So 5 to the 1/4 equals the 4th root of 5. 2 to the 1/7 is the 7th root of 2. B to the 1/n is the nth root of b. B to the 1/2 is the square root. You can put a 2 here. If there's nothing there, it's assumed to be a 2. So b to the 1/3 is the cubed root of b. B to the 1/4 is the 4th root of b. So 121 to the 1/2 is the square root of 121. And that's 11. The 4th root of 256, and let's say you don't know this off the top of your head, what you could do is grab your calculator, and you need to type in the 4 first. And then you need to type in this, which is the x square root button. So if you have a graphing calculator, it's under math number 5. If you have a basic calculator, it just looks like that. Yeah, that's how mine is second y to the x. And it looks just like this. So, alright, so that answer is 4. And that means that 4 times 4 times 4 times 4 is 256. So that makes sense. And this means the 4th root of what is 81? And that would be 3, because 3 times 3 is 9. 9 times 9 is 81. And this is the 6th root of what equals 64, and that would be 2, because 2 times 2 is 4, times 2 is 8, and 8 times 8 is 64. I'm kind of thinking of it like this. 2 cubed is 8, and 2 cubed times 2 cubed is 2 to the 6. And for the last page tonight, this is when you have actually a fraction. So this is the 4th root of 16 cubed. So this is 2 cubed. So 2 times 2 is 4, times 2 is 8. And this is the 5th root of 1 squared. So the 5th root of 1 is 1, and 1 squared is 1. And this is the 3rd root of 27 to the 4th. So 3 times 3 is 9, times 3 is 27. So this is really 3 to the 4th. And 3 to the 4th is the same thing as 3 squared times 3 squared, which is 9 times 9, which is 81 is your final answer. You could put this in the calculator just like that in a parentheses. It's probably just easier to do it by hand. So that's all for tonight. Have a great evening.